This is a 6th grade lesson from lesson 4.3 of our Math in Focus textbook, where we're talking about real-world story problems, and they're involving ratio. So I want you to take a look here. We have only assigned numbers 1, 2, 3, and 5, which are due the next time I see students. My Today class on March 5th. Your assignment won't be due until March 7th, which is on Wednesday. If this isn't your class, well, that might affect things mildly when I see you next. But anyway, if you take a look, it says we need to solve and show our work. I want to remind you that you could actually find examples of these problems in your student's note packet. That note packet that's supposed to travel with students every single day. And not only that, we've also broken the notes packet into some math maps. These are some thinking maps that our 6th grade math team created to help students work through some challenging problems. And you could find those at the back of your notes packet on pages 18 and 19. So that might be worth looking into. In fact, I'm pretty sure number 1 is similar to the map on page number 18. So if you're looking for that in your notes, that's probably where I direct you first. All right, let's take a look. For number 1, it says, a group of students surveyed chose baseball and soccer as their favorite sport in the ratio of 3 to 8. Part A, if 132 students were surveyed, find the number of students that chose soccer as their favorite sport. Well, if you take a look at that math breaker map that we made for you, it would tell you first to draw or demonstrate the ratio with a model. So I really want to draw that idea of 3 to 8 using a bar model. Also notice that on that math map, if you're taking a peek, it encourages you to use the same size pieces. Mine aren't perfect here. I see some are a little bit larger than others, but I tried to keep them pretty similar. Now before I move on, we also have to make sure that we have good labels on our bar model. So this 3 really belonged to the first thing they surveyed, or the first group they spoke of. A group of students surveyed chose baseball. Baseball comes first. So I'm just going to label this with a B for baseball. If you read on, this 8 goes with the second thing they're comparing. They chose baseball, that was the first term, and soccer, oh, that's the second term. I'll give it 2 lines or write a little 2 here. I'll use S to represent soccer. All right, now we're ready to apply part A. It says, if I have 132 students that were surveyed, find the number of students that chose soccer as their favorite sport. Well, looking at that math breaker map on page number 18 for this one, you would notice that it asks if we have the part or the whole. So I'll ask you the same thing. If it says 132 students, does that mean just the baseball students? Does that mean just the soccer students? Or does that mean all of them? Oh, it's the whole, it's the total. So I'm going to label both of these bars a total of 132 students. I also like to label my bar to show what I'm trying to find. So it says, find the number of students that chose soccer. Oh, soccer will be the question in a minute. So I might come here and say, hey, S stood for soccer. In a minute, I want to figure out how many students are represented. Now we're really ready to dig into our math skills and our math map a little bit more. If you follow the math steps, it will move you on and it will say, if you know the whole or the total, which we do, it tells you to divide by the total number of units or boxes. Well, the total number of units or boxes are over here. I could count them up and see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There seem to be 11 of them. So I'm going to divide by 11 units. Well, you could check your multiplication facts. You could go ahead and do a long division. Somehow we want to break this into a number of how many times 11 goes into 132. 11 doesn't go into 1, but it goes into 13 once, so we'll subtract 11 here. Looks like when I subtract, I'm left with 2. And I'll bring down the next place value. 11 does go into 22. It goes in there twice, because 2 times 11 is actually 22. It checks out. If you notice, this number that I have at the top, that just determined that there are 12 students in each. 12 students in each little tiny part of my bar model. That means that there'd be 12 here, and here, and here, and here, and every single one of these little tiny boxes. Every unit is worth 12, or 12 students in this case. So now we're really ready to follow that math breaker map, or we're ready to use our next skill to answer the question. So it says, how many soccer players were there? Or how many students chose soccer in the survey? If you notice, there's 12 in each of these little boxes. That's 12 in 8 little boxes. I know something. There's 12 in each, and I want 8 groups of that. 8 units or groups or boxes. It's the same as multiplying. And 12 times 8 is actually a fact I hope you know, 96. Now notice this is a word problem, so if they give you words, give them words back. 96 what? We'll go back to your question. Find the number of students that chose soccer as their favorite sport. So I know these are students, and I know they chose soccer as their favorite sport. And maybe turn it into more of a word form of that number, but we get the idea. I want to fast forward, well, or move ahead, not maybe that quickly, but to part B here. If you notice, part B should be related to the same problem. So I'll kind of keep both of these parts ready for us. It says in part B, if 56 students chose soccer as their favorite sport, alert, alert. This starts to bother students really quickly. 56 students chose soccer, it says, but a minute ago we came up with a different answer. Well, this is actually a different problem. It's still based on something that we learned here in problem number 1, but it's kind of unique in that it's a different situation. So let's go to our page 18 map again. Page 18, your math breaker map, it would tell you to draw the original ratio. Well, I don't see a ratio for part B, or do I? Oh, it's up here. There it is. The original ratio. I'm going to draw it again because it's going to represent something different this time. 3 to 8. And if you remember, the first number went with baseball. The second number goes with soccer. But this one's a little bit different, and this is important to see and to recognize. Here it says 56 students chose soccer. Let's think, is that the total number of students altogether? Or is that just a part of the students? Oh, soccer is just a part of the problem. So that means that this bar of soccer is the only place that gets labeled 56 students. Well, in a minute they're going to ask me to find the number of students that chose baseball as their favorite sport. So I'm going to circle baseball, put a question mark, and also show you on my bar model. In a minute, I hope to be able to find this answer. So how do we go about that? On your math map, it will tell you if you know the whole, divide by the total number of boxes, like we did last time. But if you know the part, which we know the part, divide only by the boxes that that part represents. Oh, so I have 56 students, and I'm dividing them into 1, 2, 3, 4, 5, 6, 7, 8 groups or units. I hope you know that 8 times some number gets us 56. I hope you're thinking there has to be 9 in each. 9 times 8 is 56. Oh, actually it's 72. I made that up. Let me backtrack here a quick minute. Alright, so actually, we want to try that again. 8 times 7 is 56. So there's 7 in each. Let's go ahead and label that. 7 in each of these little tiny units or boxes or parts. And I'll be ready to answer my question. So following that idea, after we divide, we get to multiply usually. And in this case, I'll do exactly the same. I'm trying to figure out the baseball students. So here they are, 3 boxes or units of them, and 7 in each unit. That really means 7 each times 3 groups or units gets me a total of 21. 21 what? Oh, find the number of students that chose baseball. This is 21 students that chose baseball. Now notice, I don't want you to get turned around with this one. You really had to build 2 different bar models. It's kind of like 2 different problems, but they both relied on this ratio of 3 to 8. I'm going to fast forward here with you and see if we can try a couple more together to get you going in the right direction. So here we are looking at number 2, and it says Lily is making granola. She uses almonds, walnuts, and pecans in the ratio of 4 to 3 to 8. Lily uses 40 ounces of pecans. Find the weight of the walnuts. Really the only change that I see happening here, the only real difference compared to the previous problem is this. I have a 3-term ratio. So let's go ahead and draw that out. As soon as I hear a ratio problem, I like to think of it visually. Helps me break it into pieces or steps. So 4 to 3 to 8. Now we have to make sure that we do some good labeling here so that we can answer our question correctly. So what does the 4 belong to? The first ingredient was almonds. What does the 3 belong to? The next ingredient in the granola was walnuts. The last ingredient is pecans, so we'll label it. All right? We're missing one piece here. It says Lily uses 40 ounces of pecans. Well, does that mean she uses 40 ounces total of all these things? Does that mean she uses 40 ounces of just the almonds? No, notice it says 40 ounces of pecans. That is just a part of the ingredients. So I'm going to find the bar that represents pecans and draw kind of a bracket here or a brace and show you that's 40 ounces. I'm going to write OZ for ounces. That's an abbreviation we can use. The question for part A says find the weight of the walnuts. Oh, sitting right here, they're trying to figure out how much the walnuts will total. So what I like to tell my students in class, whether they're using the math map or not, here we have the part, and we have the boxes that they represent. I always say chase the number. So the only number I really see sitting here in my bar model is this 40. We're going to chase it and see what does it belong to. 1, 2, 3, 4, 5, 6, 7, 8 units. We're going to divide that into 8 units to see what we get. Well, 8 times something is 40. 8 times 5 will do it. So there must be 5 in each. 5 in this unit, in this unit, in this box, in that box, in this part, in this part, in this part as well. What about these other boxes or units? Would it be true here also? Absolutely. In a ratio, if we're using the same size units, they're all worth the same value. So I think we're ready to answer part A. How can we determine this question mark? How many ounces of walnuts are being used? Notice there are 1, 2, 3 boxes, and there's 5 ounces in each. That really means I have 5 in each times 3 groups or units. 5 times 3 is actually 15. 15 what? Oh, it's the weight. How are they measuring the weight of the walnuts? Well, go back a little bit. Looks like they're measuring each in ounces. So I could say ounces. And it's ounces of what? Walnuts. This is a good final answer for part A. I don't want to change too much here because I know part B is hiding back there. Let's see if I can scroll so I can show you what they're going to ask next. Here we go. Part B. Will I need a new bar model? Let's read and see what it says. Find the total weight of the granola. Oh, they didn't change anything. They didn't change the number of ounces we used of any of the ingredients. They really didn't change anything much here at all, except for the question. The total weight of all the granola. Not just the almonds, not just the walnuts, not just the pecans, the total. They're asking for this number, the number that represents all of it all together, all of the ingredients. So how do we get there? Well, first we need to know how many total units we have. I have 4, 5, 6, 7, 8, 10, 12, 14, looks like 15 units. And what's in each? 5 in each. So 15 units times 5 in each. 5 times 5 is 25. We'll regroup that 2. 5 times 1 is 5 plus 2 more makes 75. I got a total of 75 ounces. But what is this ounces of? Oh, the latest question in part B talks about granola. It's all of it together. We just found the unknown total, or the whole. I'm going to let you follow the same great math map for number 3, where you get to look at Adam, Ming, and Clinton, who sold sandwiches in a ratio of 4 to 7 to 3. You're really going to do the exact same idea, and you're going to notice here that the number you're going to chase in a minute goes to Ming. Ming made 91 sandwiches, so that's the part, and you're going to have to figure out what number to divide that 91 into to find the value of just one tiny little unit. Chase the number and figure out what one unit is worth. The last one I'd like to look with you at today is number 5. So this is unique because this is a 2 ratio problem. This actually belongs to the math map on page 19 of your notes packet, I believe. So you're going to notice that even with a quick skim, there's a ratio of 5 to 2 and then a ratio of 3 to 5. This is interesting. So looking at that math map, they're going to ask us to follow all the steps through to try to get to a good answer. Let's go ahead and read what we need to start with. Gina has a box of red, blue, and green markers. The ratio of the number of red markers to the number of blue markers, oops, I heard something important here. Red to blue is 5 to 2. The ratio of the number of blue markers to green markers is 3 to 5. What is the ratio of the number of red markers to the number of green markers? Oh, in a minute I'm going to answer this question. Okay. If you look at your math map, it tells you to either draw or to write the ratios. So the first ratio I'm given is 5 to 2. It is important that we label this ratio though. So who does the 5 belong to? Oh, the first thing they said was red. Who does the 2 belong to? Oh, the next thing they said was blue. Here's my first ratio. So on your math map, it might look something like this, or maybe you drew it out. There's also a box kind of across from that on page 19 that says write or draw the second ratio. So the second ratio, oops, I almost gave something away here. Let's try that. The second ratio actually is 3 to 5. But who does the 3 belong to? Well, the first thing they said here was blue. So this gets the B for blue. The second thing they said is 5, which goes with here, the green markers. Gets a 5. And then on your math map on page 19, they're going to say what repeats. What do they have in common? Take a look at this. Blue and blue, make up your mind. Are there 2 groups of blue markers or are there 3 groups of blue markers? Well, that's kind of confusing, isn't it? So what they're going to tell you to do is find the LCM. Let's find the LCM, or least common multiple, of both 2 and 3. See if we can find a number that they agree on so that they can make up their mind here. Counting by 2s, 2, 4, 6, 8, 10, 12, and so on. How about 3s? 3 times 1, 3 times 2. Oh, might as well stop right here. I noticed something. We found the LCM. The LCM is 6. I want to turn both of these numbers that don't agree into the same common term. I want to turn them both into 6. So how do I get there? How do you go from 2 to 6 with math rules? Oh, we multiply by 3. And if I do that to the second term of this ratio, I do that to the first. What is 5 times 3? Hopefully you'd say 15. And we get a ratio of 15 to 6. Remember, this is still red to blue. Not too bad. Okay. Take a look over here. I need to change my blue ratio so that this number 3 can become 6 so that they will agree. I must have to multiply somehow. 3 times 2 is 6. That will work. If I do that to the first term, I do that to the second term. 5 times 2 is actually 10. Oh, I have a new improved ratio. And this still represents blue to green. I'm just finding those labels up above and bringing them down so that I can see them. And you notice something really fabulous? Look at the 6. It matches. They agree. What that means is I can go ahead and answer my question now. I actually could write you the ratio of red to green markers. Red comes first, green comes next. So let me write that. Red to green. Well, where would we find our number for red markers? Well, we look for the R that we used for labeling purposes. There it is. There were 15 groups of red markers. There's a ratio of 15 to 6 sitting right here. 15 belongs to the red. How about this green? I'm looking for green markers next. So I'll do some looking in my ratios. I'm looking for a G to represent the green. Oh, here they are. Check. There are 10 groups of green markers, or maybe 10 markers, depending. This isn't bad. Okay, it looks like I was able to answer it. This would be an okay answer. This is good thinking. It's not a final answer because we talked today about using your skills of simplification. If you can simplify, oops, I spelled that wrong, but if you can simplify, do simplify. So what divides into 15 and 10 nicely? Oh, I hope you see they both divide by 5. 5 goes into 15 3 times, and 5 goes into 10 twice. This still is red to green, but it's in simplest form. This is a final answer for this problem. Might be better if I wrote red markers compared to green markers and wrote it out so that you have a little bit more for word form, but they did ask for a ratio on this one. So we've got the right idea. You might want to keep in mind this could mean that there actually are 3 red markers and 2 green markers. Maybe it means that there are 6 red and 4 green. Oh, like doubling it. Or maybe there are 9 red and 6 green by tripling that ratio. Or maybe there are 12 red and, let's see here. I feel like I did this one wrong. I doubled it. Oh, times 4, there we go. Or quadrupled it here, 12 red markers to 8 green markers. This is just food for thought. If ever they ask me for the actual number of markers, there are lots of possibilities, but this is the ratio that they mean. For today, we're going to stop our ratio word problems right there. I did encourage students that if they were feeling brave and they wanted to tackle this challenging problem, number 4, where it deals with Jason and his ratio of money to Wilson, that they definitely are welcome to, and we'll talk about it a little bit more in class when I see them again.